Excellent. Thanks so much, Riaz. Let me just get sorted here. All right, hi, everybody. Thank you so much for coming out. Can everybody hear me okay? Excellent. And amongst all of the floods, the great floods of Toronto, which were threatening to cancel us, but we all made it. So the majority of this session is going to be live coding. That's kind of the format I like the most. That's what I try and go for. But I do have a bit of preamble at the beginning. So we're going to do 5, 7, 8.5 minutes of slides maybe, and then half an hour-ish of coding, depending on how many mistakes I make. There's at least 2 errors I'm going to make. No matter how many times I have practiced this or written it, I will make them, so I'll need your help debugging maybe. But yeah, we're going to be building a mini Webpack from scratch. And some of you will be like, ooh, others will be like, what does that mean? And so we're going to start off by making sure the recording is working. We're recording. And then what is Webpack? And the answer to that is Webpack is a module bundler. And that is more confusing than the question in the first place. So we need to ask what a module bundler is. And the answer is a bit more complicated than this, but ultimately, assume you have a bunch of source code in your project. It's a bunch of JavaScript files. Because we're focusing on Webpack, it's mainly JavaScript focused as it stands. You've broken it all into separate files because we like having files, we like having modules to organize our code. You feed those files into Webpack, and it spits out a single JavaScript bundle for you. And that's what a module bundler is. And that really begs even more questions. Why do we even need module bundlers? Why would we do something like this? No other language really has something like this. This seems sort of silly. Why would we bother? So why do we even need module bundlers? Because JavaScript did not have a module system for a very long time. The typical habit was just to include script tags on your web page and share state with window, and everybody was happy with that for God knows how long. It was a really long time, and there was a lot of scary stuff we had to do because of that. In 2015, we did get a standard module system spec'd out by ECMA. And they're called ESM, ECMAScript modules. And if you've written JavaScript code in the last 10 years, you've probably been using this syntax. So we'll go over what ECMAScript modules are quickly. So if you want to import something from another file, you're using the import statement and from path to file. You can do default imports and named imports. The difference is not super important here. And then if you want to export something for other things to be imported, other things to import, you're using the export keyword. And that's the standard module system for JavaScript. So as of 2015, we can rejoice because it actually exists. In reality, things are not quite that simple. So despite being spec'd in 2015, and the dates may vary on this exactly, but ECMAScript module support landed in browsers in 2018 and in Node.js in 2022. So on the front end in 2018, but on the back end in Node.js in 2022. In 2020. I think I said 2022 the first time. So it's very recent for a very ubiquitous language to have just gotten support for its standard module system. So in the meantime, long before even the ECMAScript standard for modules was created, other module systems cropped up. And the one we are going to care about most today is called CommonJS. And in reality, even if you're using ECMAScript module syntax in the code you're working on, the packages you're using are, many of them, I would want to say maybe the majority of them, are actually using CommonJS under the hood. So we're going to take a look at ECMAScript modules versus CommonJS quickly just to see the equivalences between them. So this is the same example we had from the other slide. This is ECMAScript modules using import-export syntax. CommonJS uses require instead of import, and you'll notice that it's a function call instead of a statement in your code. And there's these 2 globals called exports and module that get injected for allowing named exports and default exports. So they look very similar on the surface. CommonJS is not standard. And that's why browsers will never support CommonJS. But Node.js has always supported CommonJS and will continue to support that for a long time to come. just because there's so many packages that in the time that we were writing code before support landed for ECMAScript modules, there's just so much code that's using CommonJS. So one important point to note about this is that you can only use CommonJS code in a browser if you're using a module bundler, because browsers have never supported CommonJS and never will. So to summarize the value of module bundlers, they let you break your code into separate files without having to use global state like window, even if your runtime doesn't have a module system, which sounds absurd but was true for the longest time. It lets you use non-standard module systems like CommonJS. If you've heard of AMD or Require.js, there's other ones that exist and have cropped up. So even for code that targets the browser, so your environment does not have to support the module system you're using, and there's huge value to that. And it lets you mix module systems together, so you can use a combination of ESM, CommonJS, Require.js, whatever else you like, your own module system you can make up. Your module bundler lets you do that. And just to summarize, yes, JavaScript was a big mess, and some of the mess that continues to exist, tools like Webpack help us get around a lot of that. A few other notes I'll go over very quickly. We're going to focus on the module aspect of module bundlers today, but there's a lot of other things that you will probably more commonly do with them in your day-to-day work, such as minification, dead code elimination, code splitting, and I could list like 70 other things that you can do with module bundlers. We're not going to talk too much about those today. Another note, which has become more recently relevant, I would say, is that ESM plus HTTP2 support in browsers mean that you can maybe envision a day where module bundlers are not needed. I'm not going to talk about that because that's its own whole can of worms, but I do want to acknowledge that, is that giving this talk 5 years ago, I would have been saying Webpack's your only option. And now I'm saying maybe 5 years in the future, we'll see a place where we're just using ECMAScript modules for real everywhere. And there are lots of other module bundlers. Webpack is, dare I say, the most popular, but definitely not the most performant as far as tools like ESBuild tell me. But I could list probably dozens of them that claim to do similar or other things. And we're focusing today on the module bundler concept, less so much the specifics of Webpack. Although they do share, I want to claim that they share the same core fundamentals, which we're going to be covering today. So why do we bother building one from scratch? They are ubiquitous. So kind of mentioned this already. I want to say that the vast majority of front-end apps, certainly everyone that I've worked on, has used a module bundler. Most of the time, they just sit there and they do their magic, and you don't have to worry about them. But then maybe you update a dependency, or you have some syntax error in your code, and it spits out a giant red blob stack trace that doesn't really help you. So when things go wrong, they're very, very difficult in many cases to figure out what's going wrong. And I believe that understanding how your tools work is the best way to be able to debug them when things go wrong. Understanding how your tools work is the best way to use them to your full potential. So as we mentioned before, tons of stuff you can do with module bundlers. And the fundamentals kind of unlock a lot of that power. And I believe the best way to understand the inner workings is to build something from the ground up. And this one is fortunately quite digestible, I would think, to get everything sorted. I wouldn't recommend doing this with everything necessarily, but module bundlers are a good thing to build from the ground up. So what's our approach going to be? We'll quickly review what the strategy is going to be at a high level, and then we'll dive into the coding. So one thing to note, we're going to be doing everything in CommonJS for simplicity. The reason for this is subtle but important, and we can maybe discuss it later on. But don't worry about ECMAScript modules anymore. We're just going to be using CommonJS. I have pre-prepared kind of a small set of files that we're going to be bundling. So it's just a mini nothing project that does some console log statements, just for us to verify the behavior and to make sure that we're bundling things correctly. So the first step, so these are the 3 key steps that we're going to be doing in the code. Step 1, we're going to accept an entry file as input. So that's the only input that we're going to be accepting to our mini module bundler. It's going to be the relative path to an entry file. So that's the root of our application. Step 2, we're going to somehow figure out all the files that the entry file depends on. So everything that it requires using CommonJS, and everything that the things it requires, et cetera, until we've got everything into that bundle that we need. And then we're going to bundle all those files once we've determined them. We're going to bundle them into a single file. So thinking back to that diagram at the beginning, a bunch of separate JS modules, feed them into our module bundler, and out spits a single file. And the last bit of prerequisite knowledge, abstract syntax trees, many of you have probably heard of them, but they are basically just a data structure representation of code. So what does that mean? We're getting a bit meta here, but if you take a very simple hello world program like console.log, we feed that into a parser and it spits out an abstract syntax tree for us. It looks something like this. And I trimmed down quite a bit here. There's a lot more metadata you can include in an abstract syntax tree, but one of the key things to note here is that within this data structure, this is just a JSON object with some pretty formatting. You'll notice that console.log is identified as a call expression here. So we have this call expression, its name is log, and it's being passed the value hello. And obviously, for a more complicated program, you just have more nesting, you'd have more information about what do these tokens in my program represent. So today we're going to be using abstract syntax trees. Just want to make sure everybody has the same foundational knowledge for understanding what are we doing when we're calling these magic functions. And speaking of libraries we'll use, so in order to generate those abstract syntax trees, we'll use a library called @babel/parser. For traversing those trees, so just walking that JSON structure in a convenient way, we'll use Babel traverse. And then Babel generator just does the opposite operation. It takes an abstract syntax tree and it gives you back JavaScript code. So yeah, not quite totally from scratch because we're using these libraries, but they really don't make up much of what we're doing today. They're just very convenient to explain concepts. Any quick questions before we get started? I will take that as a no. OK, let's jump into it. We'll finish the presentation. I'll hop over to the terminal. Does this appear to be large enough for everybody? Thumbs up, yes? Excellent, thank you. All right, so first thing we're going to do is take a look at the project that we have set up here. So just look at the source directory for me. And here is this entry point file that we talked about. And there's a few lines of code in here. So the main thing that this is doing, it's importing, conceptually importing, syntactically requiring a log function. If we take a look at this log function, it really is just a wrap around console.log because I wanted to put console.log in another module. And then it just module.exports that, so that's the same as a default export. So we're importing that. We're importing two functions from two other modules. And these are also very simple modules. They just use our log function to log something else to the console. And our entire program, all it does is print 4 lines ultimately, but we have it broken up into other modules because, big brain time. More modules, better. So we have the 4 log statements, and then this will happen only in the browser once we do some confirmation. I've called this module fun, and it ultimately just sticks an image into the browser when we're in a browser environment. We won't see this until the very end, but we'll be taken to Flavor Town apparently. And so we'll just confirm what happens when we run this program. So I'm going to use Node.js, and I'm going to run our entry file. And we should see those 4 lines being printed out. Master of the house, doling out the charm, open pawn, pressure appreciated by. We're good, in order and everything. So that's cool. And that's running in Node.js. So if we take a look at, let me make sure. Yes, we do not have a bundle there. So I also have a teeny tiny index.html file here.
I think it's cutting off line 1 at the top there. We see on the actual.
Oh, you're right, indeed. Thank you. Let us unfull screen this and shorten the window. Are we good? We're good. So I'm actually very practiced at that because Microsoft Teams, which I use at work, you need to do that for Windows because the thing that normally you can just move around with Zoom doesn't let you move it around nicely. So yeah, be amazed at my skill at shortening windows. So we have a tiny index.html file here that's going to, so we're going to see what happens when we open our entry file in the browser. And we already know that CommonJS doesn't exist in the browser. So we're just going to open index.html, and nothing happens. And the error that we see is, so bundle.js doesn't exist. We're going to be building bundle.js later. It tries to pull entry.js into the browser, and it says require is not defined. And that's the browser's way of telling us, like, why are you using CommonJS, man? Like, come on. And so if everything works, once we've built our module bundler, we'll be able to run the bundle via Node.js and load the bundle into this index.html file and see the same output. So we'll see those same master of the house lyrics getting printed out. And that is about it. So let us create a file. And we're going to call it bundler.js. Actually, let's call it something more exciting. I'll call it lilpack. So this is our little module bundler called lilpack. And we're going to sketch out what we're doing. So we're starting with those 3 steps that we listed. So first step was accept input as entry file. The next step was determine all the files we need to bundle. And the last step was generate the final bundle. So those were the 3 things that we sketched out. We're going to start with the first and the easiest one, and that's to accept input as an entry file. So what we want to be doing here is we want to run our lilpack file, and then we're just going to pass it as the first argument source/entry, and nothing happens now because we're not actually reading that input. So the way we do this in Node.js, so this is going to be entry equals and then we're going to confirm that we're printing out the correct input there. So if we run this command again, we see that we're indeed getting this relative path. And the first thing I'm actually going to do is convert this to an absolute path. So this is a bit arbitrary, but I'm going to use the absolute path of each file as the identifier for that file as we're pulling them in and bundling them. And that's mostly just a useful debugging device, but we could use like a numeric identifier. But ultimately, we need to identify the file uniquely somehow. So we're going to use the absolute path of that file. So we're going to, path is just a built-in Node.js module for operating on file paths. And the way that we're going to get the absolute entry path is just to say path.resolve. So there's a few things going on here. We'll take a look at it afterwards. And then we're going to log that absolute path at the end. So what exactly is going on here? We're just saying, OK, we know we're given a relative path as our input. We're just going to join it to the current working directory of the process that we run, which is our working directory of our project. And then we're going to tell Node.js, please remove any useless path segments so I can successfully read this from disk. So if we take a look at our output now, oh, we ran the wrong file. It's this one. So we now see that we're printing out the absolute path of this entry file. So now we basically have that as the identifier for that file. And we're done step 1 already. How about that? That's pretty exciting. So I'm going to remove this log statement. I'm going to skip over the determining all the files we need to bundle for now, and we're quickly going to do a teeny tiny example of what we're actually going to be outputting from this program. So we're going to call this variable bundle. This will be our final bundle, and it's going to, so we're going to write some code inside our code using this string. And for now, it's just going to be an empty iffy, an empty immediately invoked function expression. And it's not going to do anything, and then we're going to fill this in. Fill this in with some stuff. And this stuff is going to be determined in step 2. So we skipped a bit ahead to step 3, and then we're going to console.log bundle. And then the full kind of development flow we're going to follow here is we're going to run lilpack. We're going to pass in the source entry.js. We notice that it prints out our final bundle code to our console. So we're just going to actually pipe this into a bundle.js file. And then if we open up our bundle.js file, this is where our final bundle is going to live. So we just need to fill it with stuff now. So we're back to our source code. And we're getting into the weeds of this. So there's some stuff, probably 1 or 2 things that's going to be maybe a bit confusing depending on what programming concepts you're familiar with. I will maybe try and call those out specifically, but don't worry if you get lost at any point, or if you're familiar with this stuff already, maybe it's just obvious to you, that's fine as well. I'll try and be as explanatory as possible without being too pedantic, so thank you for bearing with me. So the strategy we're going to do here, we know we're using CommonJS. So we know that our modules are filled with require statements. Those are the statements we care about because those tell us the other files that we need to pull into our bundle. So we need to find all the require statements. That's our goal. Find all the require statements. Require statements. And get their absolute pass. So I'm going to declare this is a stack or a queue. It's probably just a stack. So I'm going to use a stack here. It doesn't really matter. I'm going to call it files to process. And it's just going to be an array with a single element, and it has our entry point in it. And then while we still have files to process, so while the length of our files to process array is greater than 0, we're going to process each of those files to find the require statements. So the first thing we need to do is files to process. So we'll call this variable current file. So pop is just going to take the first element, or whichever, the first or last, it does not matter in this case, but it's going to take an element off of our files to process array. So for our first iteration, it's just going to take our entry path, remove it from the array, and store it in this variable. Now we need to find the require statements in this file. And for this, we're going to use Babel parser. So we'll head back up here and we'll import, if I remember the import statement here, equals. So I have installed these dependencies beforehand just for the sake of convenience here, but these do exist in our node modules and installed from npm. And we're going to say, and we need to parse the contents of that file. So we're going to be reading that file using the file system APIs. So this is file contents. Contents equals fs.read file sync current file. And we need to specify that it's an UTF-8 or else we get a buffer. So once again, file system APIs are just provided by Node.js, similar to most other languages. Read file sync just takes the absolute path of the file. We can use a relative path as well. In this case, we have the absolute path. It gives us the contents of that file. And now we're going to parse the contents of that into an abstract syntax tree. And for the sake of making sure we're on the right track, let's console.log this and take a look at the abstract syntax tree for our entry point. So let's no longer write that. OK, so we see something similar here to what we saw on that slide earlier. So it seems we have successfully parsed the abstract syntax tree. It's pretty huge, even for the small program. We're not going to dive into it. But this now gives us the power to identify all the require statements. This is the key point of using parse here. And the way we're going to find those require statements is using Babel traverse, which we talked about earlier. The import's a bit wonky here, but we are using CommonJS. That's the reason for it. So the traverse function accepts an abstract syntax tree over which you are going to traverse, and then a bunch of visitors, which is a fancy way of saying callbacks for functions for things that we want to tell it to visit nodes of the tree. So it makes much more sense if we just go and do it here, I think. So we're going to traverse our AST, and then we need to tell it what to visit. We want to tell it to visit our require statements. And I think the easiest way to do this, let me actually shorten this window. We're going to hop over to a tool I love called AST Explorer. We will enhance. And we have here, AST Explorer just gives us like a nice UI for actually looking at the abstract syntax tree that we have. So we're looking for function calls to require. How do we get to them? We just stare blankly at this abstract syntax tree? No, we can just like click on the require, and we see that, oh, we're looking for a call expression whose name is require. And we can get its arguments in this argument's string literal value here. So this is, we've also set the parser to Babel parser here, which is how you know the syntax tree is going to look the same as the one that we're generating. So if we hop back over here, the syntax for this is you basically define a function here called call expression, and then it gives you a node. So this is saying, I want you to find every call expression in this AST, and I want you to call this function for those call expressions. And we're going to say if, so we'll head back to AST Explorer. We know that we only want to look at require calls, because we have lots of function calls in our program. We only care about the require calls. So we're going to say, if the call expression, if the node.callee.name is require, that's the only time we want to look at stuff. Otherwise, we don't care. So we're going to say if node.callee.name does not equal require, we're just going to return early. We're going to do nothing. Otherwise, we need to extract the first argument from that call to require, because it's going to tell us the path of the file we need to bundle. So how are we going to do that? Once again, we head back to AST Explorer. We know that we have this property arguments, and it's an array of arguments past this function. We only care about the first argument. And we're going to grab the value property out of the abstract syntax tree. So here, this is going to be relative path. We'll call it dependency relative path. So this will be the relative path to the argument, to the call to require that we're pulling in. So this is going to be node.arguments at 0.value, if we remember correctly. And then let's log this to make sure that things are behaving as expected. So if we go back to our entry point file, if what we've done is correct so far, we should be seeing every call to require. So we have 4 calls to require here. We should see the relative, we should be extracting 4 string tokens and printing them out based upon the current bundler. So we should see log/dir/module1/dir/module2 and /fun. So let's see if that worked. So it looks correct to me. We're logging some other stuff there, but these are the log statements from what we're pulling out of those require statements. So I think we're probably good to proceed. What else are we console logging? Right, so let's stop logging the AST now, because we have the things we care about. And now, going back to the very first file, we wanted the absolute path of that file to use as its identifier. So now we want the absolute paths of these files to use as their identifiers as well. So now we want dependency absolute path. And we'll use some Node.js built-in libraries to help us obtain that path. So this is one of the hairy bits, so don't worry too much if basically it's quite a simple operation, but it is kind of confusing to see it written out with the Node.js stuff if you're not familiar with it. So we'll try and explain this here. So this is one of the parts I always mess up as well, so we'll see if we get it right. So to get the absolute path, we're going to do something similar. So we're going to be calling path.resolve like we did above, which is just saying, Node.js, please remove any redundant path segment so I have like a well-formed absolute path. And then we're going to path.join. So we know that the relative path that we have is relative to the file we're currently in. So the file we're currently in is conveniently called current file. Thank you, variable names. So we have current file. And we want to join that to the value that was passed to require, which is the dependency relative path here. And this is not quite the absolute path. So we'll take a look at what's getting printed out here. We'll actually move on a bit quicker here. But basically, we need to actually resolve it relative to the directory of the current file. So right now, what we're doing is joining the current file, which has like a log.js on the end, for example, and we're joining it to the relative path of the dependency. We need to just go up one directory and use the directory of the current file we're in. And then we can just use path.dirname to get the current file here. And so now we'll log these out. Console.log dependency absolute path, and we'll verify that we are indeed okay, so this looks correct to me. We are missing file extensions. So we'll see if that comes back to bite us. But these are the absolute paths of the files we care about. Actually, no, it's not. Path.dirname current file. So we're missing something with dependency relative path here. And for some reason, yes, we should be seeing, actually, if we go back to the output here, I'm sort of thinking we should be seeing log.js here, but we'll see if that comes into play here. I may have never just logged at this statement before. So we're just missing the file extension, basically. And we may actually want to, we change this instead to require.resolve. We end up getting what we want. So this might not have mattered, but this is just a subtle difference between require.resolve and path.resolve that we can come back to later. Require.resolve will give us the file extension in this case. So we do have the dependency paths of all of the absolute paths of all the dependencies that we need now. So this is good. And we know that we need to, dare I say recursively, but iteratively process those dependencies as well to determine all of the absolute paths of all the dependencies all the way through our dependency tree. So we're actually going to files to process, push it onto our files to process array. So this should walk the entire sort of dependency tree that we have, fill our files to process array, and then process them as we're getting it. So at the very end, we're going to be having a files to process length of 0. And that's our stop condition. So what do we do at that point? So we've parsed everything, we've processed everything, we know everything. We're not really saving anything anywhere right now. So I'm going to cheat slightly and just use a data structure that I know will be useful in the next step. We're going to say a module ID to AST map. We'll define this object here. And this is where we're going to store absolute path key value pairs to the AST of that module. So we'll say, once we've parsed it, we have the absolute path in current file. So we'll say module ID to AST map equals, or at current file equals AST. So now we have something that we can use for our next step. We have every file that we need to bundle because we walked the dependency tree. And now inside our module ID to AST map, we have everything we need to generate the final bundle. So let's just verify that it has stuff in it. So console.log module ID to AST map, and we'll actually log the keys as well. Okay, so here are the keys that we logged. So this is good. These are all of the paths that we looked at earlier in our project. And we'll notice that the dictionary we logged above does indeed include the ID of the module, the absolute path, mapped to the AST for that module. So the next step, we've processed everything. We have everything we need. We're done step 2. So we can move on to step 3. I'm going to declare a variable here and come back to it later. I'm going to call it module registrations. It will eventually be a string. But now we need to fill in the contents of our bundle. And one of the key points to remember here, browser does not support CommonJS. Our code uses CommonJS. It has these values require module and exports that it needs in order to run. So the first step to build our bundle, we need to implement CommonJS in our bundle, which sounds scary, but it is actually quite simple. Some parts look weird, but it's basically saying, here's a require for you to use, here's a module here for you to use, here's an export for you to use. Do what you normally do in Node.js. So we're going to define a map here called modules. We're going to interpolate module registrations here, which we haven't done yet, remember. We'll come back to that. And then I'm going to implement a function, I'll call it lilpack require. And it is going to be a function that accepts, so if we take a look at our entry path, require just accepts one argument, it's the relative path to the module. So this is, we're going to expect the module ID to be coming in here. We're going to, when require is called, the effect that happens in Node.js, it gets pulled in. We need to do the same sort of thing. We need to pull in that code to run. So the first thing we need to do here, I'm going to define another map up here. So we're going to call it loaded modules. And this is, well, for sanity's sake, in the case that a module is required multiple times, you only ever execute that module once. So this is going to be our module cache, where if our log functions get pulled in by multiple modules, we don't end up redefining that log function every single time that happens. So this is required for the CommonJS spec, and it is actually just the most sensible way to do a module system. Like in Python, the same thing happens when you import something. If you import in another file, the Python code only gets executed once. It's sort of the same thing that's happening here. So we're going to say, if we haven't loaded the module already, we're going to load the module. And our module is defined inside of this module's empty object for now. So we're going to call that module, and here's where we inject our custom require, exports, and module functions. So I'm just going to write them out here. So it's going to be require, exports, and module. So where do we get these from? So the require function is actually just lilpack require itself. So the function we're defining is calling this function and passing itself to the thing it's calling. One of the bit confusing things here, and it will maybe bend your mind a little bit, but it makes perfect sense when you actually end up stepping through the final bundle. And then for exports and module, so this should be exports, we're actually just going to define them right here. So we're going to say var module equals exports. They can just be empty objects. So we go back to our entry point, and we look at how our entry point doesn't actually use module and export. So if we head to this directory, it's just using the object syntax like it's a plain object on exports. And if we head to our log function, it's using module.exports just like it's a JavaScript object because it is. So we're just going to define plain JavaScript objects, and then we're going to pass them when we're calling our module that we're requiring. So remember, we still haven't filled in our module registration, so there's still a piece missing here, but it will all come together. And so this is going to have the effect of executing the module. It's going to put values that it's exporting into module and exports. And now we can assign a value for the loaded module to be whatever was put into module.exports by the module. So this is the code that makes everything work. And it's like 3 lines, and it can be very confusing. So don't worry if it doesn't make too much sense right now. It will when we step through it. This is it. This is CommonJS implemented. And all we have to do here is return loaded modules at module ID. So we can verify our bundle is getting output correctly if we just run Webpack again. So we see the bundle that's being printed out is just exactly what we have hard-coded into that string. We're not doing anything else. Module registrations is empty. That's the last big mystery here. So coming back to module registrations, we know that our require function is pulling modules from this object by their module ID. So we need to define each module, and each module is going to look something like this. So we'll say modules we'll interpolate module ID here. It's going to equal, so module ID is not defined yet, we'll come back to that. And then it's going to be a function, because if we look back at our require function, we're calling the module as a function, and we're passing require module.exports end module. So it's going to accept require module.exports end module. And here it's important that we use the same identifiers that are getting used in our modules. So if we used the name Webpack require there, it would be like require is not defined because we're not injecting a require function. And then the contents of this is just going to be literally the AST that we pulled from the file serialized back to JavaScript code. And for this, we're using Babel generator, which we talked about earlier. So we'll go up babel/generator.default. So we're back down to our bundle now, and we'll scroll up to the module registrations, and we'll just say generate ast.code. So this is only an example. We're going to iterate over all the modules and do it for each of them in a second, but just pay attention closely to what each of the modules it's doing. It's registering itself by setting its module ID in that modules array to a property that is a function. And that function lets us mock CommonJS paired with our require function. So now we actually have to, so we'll call this module registration. We'll redeclare module registrations. And then we'll iterate over all of our modules. Module ID to AST map. We'll iterate over all of our modules and do this for each of them. So we'll just map over it. Here we get the module ID and the AST. So we're doing the exact same thing here. Just keep in mind, object.entries give us a key value pair of module ID and AST because that's what we defined our module ID to AST map to be here in this case. So we have this module registration, and then we need it for each of the modules. And then we need to make sure this is a string at the end, so we're going to join everything together. And is ESLint complaining about anything? No. OK, so before we look at our bundle, finally, let's take a look at what the module registrations look like. Let's actually comment out this guy as well. So for each module, so let's take a look at our log module because that's quite simple. It is registering itself on that module's object using a function where we're passing in require exports in module. And then this is just the source code that was in that module. We just have our log function, it's wrapping console.log, and it's using module exports log, and it will work because we're giving it a value for module and exports. And one thing I do notice here, I even said it was important to use the right names, and nobody corrected me, come on. But yeah, it would not work if we did not use exports there. So now, our final bundle, is it ready? No. Correct. Spoiler alert. But yeah, I've intentionally, this is another mistake I always make, but I've actually intentionally left it for the very end because it's like the final kicker. So let's put back to console.logging our bundle here. So what is it actually doing? So let's actually write this to a bundle.js file. And if we run our bundle with Node, we'll see what happens. So if we do node bundle.js, invalid regular expression flags. That is not the error I was expecting, but it is an error. It's the fabled third mistake I always make that I forgot about. So that is actually just because we are missing some quotes here. A very unuseful stack trace. A very unuseful stack trace. We might be missing quotes in a few places, so we'll see what comes up. But that is definitely one spot. And this looks to be another spot because I did not regenerate the bundle. Okay, cool, but it's not doing anything. Partially because we're not telling it to do anything. We need to kick it off at the very beginning, and how we kick that off is just by calling a little pack require on our entry point. So we'll remember our quotes this time. So this starts off the whole require cycle where all the modules get pulled in, they all get executed, they all get loaded into the cache, they all get required into each other, and then the program executes. So now is our bundle ready? So let's see. Module ID is not a function. Modules at module ID is not a function. And that is partially because, once again, not a very helpful error message, but if we think about what we're doing again, our little pack require function is expecting the absolute path of the module. So if we go to our bundle.js file that we generated, which is not in Git, tab new, bundle.js, and we'll just format this. So we're registering all of our modules correctly using their absolute identifier, but you'll notice that the modules themselves are still using the relative paths because, well, our source code used relative paths, right? We don't, so how do we rectify this? We need to modify the code somehow to tell it, okay, I actually, instead of this relative path, I'm now using the absolute path as a module ID, so please use the absolute path. And it turns out the answer is quite easy. We can just use Babel traverse. So if we go back to Babel traverse, if you remember way back in step 2, when we were going through our call expressions and we were feeling so great because we had the absolute paths, we made a mistake that we always make, and we forgot to modify the AST to modify the argument to require there. And it's actually just as simple as saying node.arguments at 0.value equals dependency absolute path. So what this is doing, this is mutating the AST for each file so that the require gets the right argument inside the body of each file. And then when we generate the AST here, we should see that code modified to use the absolute path. So let's verify that. Yes, please. All right, so if you look at our entry.js, look at that. Our require carls are now using the module IDs, which so happen to be the absolute paths here. So now is our bundle ready? I actually think it is ready. I hope it's ready. So we'll see. We'll see. We'll do this. We'll run it with our bundle, and if it is ready, we should see master of the house lyrics getting printed out. Success. And if it's really, really ready, if we're not just faking and using the actual CommonJS stuff in Node.js, because CommonJS still exists. It doesn't exist in the browser, so let's open index.html, which, if you remember, already included our bundle. Flavortown. And then if we open the console, which is actually the stuff you really care about, you'll see our entry.js still requires not defined because that's our Node.js source code. But our bundled code in our bundle.js is indeed logging our master of the house lyrics. Whether or not Guy Fieri is your master of the house remains to be seen. And that's pretty much it. There's a lot of stuff that we did there, but I would ask you to focus on the key parts. Is we're using a parser, we're traversing abstract syntax trees, and we're generating code. Those are the three key things that all module bundlers have to do in some extent. And they'll all tell you they do it more performantly than the others, but focus on those fundamentals. And my hope is that like the next time you see this big ugly stack trace that's in your Webpack config you haven't touched in months, if you have to go reading source code to figure out how your dependency is exporting things correctly or incorrectly, like that knowledge, those three key points, understanding that will help you be a bit less intimidated by what's going on there. Because if we take a look at our final line count, I think I promised 100 lines. Lilpack, 84 lines, including comments and console logs, so not too shabby. But yeah, that's mini Webpack from scratch, everybody. Thanks very much. And yeah, in case you forgot where Guy Fieri came from, we'll take a look at entry.js again. It was this call here, and all this module was doing was adding an image to the DOM as long as the document existed. So document doesn't exist in Node.js. It exists in the browser, though. So proof that we're not using CommonJS, but we did it ourselves. Excellent. I think we're pretty good on time. Questions? Do you have some time?
Yeah, we have a mic though, so we'll just kind of let people ask questions real quick.
Yes, questions, anything, nothing is too obscure.
Can you hear me now?
I can hear you, yeah.
Yeah. Thank you so much for the talk. It was super engaging and I enjoyed it so much.
Thank you.
I was just curious if you was to make a next step, like if it was your pet project and you would make a next feature for it, what it would be?
Yeah, so the question was, if I were to make this a pet project and I guess evolve the module bundler to be more than the bare bones, what would the next step be? So feature-wise, the next step would be supporting NPM packages. So I could like NPM install Lodash and require Lodash, and then it would pull that in. And there'd be a whole bunch of stuff involved there in terms of like making sure I'm like implementing the whole Node.js spec correctly for what happens when require is being called. So like there's like differences between if it's an absolute path, a relative path, or like no path. It's like if it's starting with a dot, if it's starting with a slash, things like that. But like I think bug-wise, something here would be like cycles. I think that would be one of the first things that comes up. If you have two modules that require each other, like they would probably fail, I think, here. We would get some sort of failures because I think our modules to process would never empty. So it would just run forever. Yeah, if we're using, yeah, but then, even then you can ignore stuff and it crops up anyway. So But yeah, the module bundler would definitely have to handle that because you can't depend on your clients not to have cycles in their modules. So those are the two things that come to mind, yeah.
Okay, thank you so much.
For sure.
Go ahead.
Thanks for the presentations. I'm just curious if, like, why is it that Webpack use AST to, like, I don't know, traverse or whatever?
I think it's just, it's very powerful. And I say this with, so I've worked a lot on some Babel plugins and ESLint rules, custom ESLint rules. And if you know what those are, you'll realize that they also involve parsers a lot. And the stuff you can do anything to your code. You can lint anything on your code. You can perform any operation on it when you have an AST and something that lets you generate the code. And it in itself is very complex. And you just remove all that complexity and enable all the power by using these simple functions. We could have, the simplest implementation of this would have been regular expressions. Like you get the string of the code, you use regular expressions to find the require statements and extract them. And then if you were to extend the module bundle beyond that, you would immediately just undo all of that and use a parser and use the ASTs. So I think this is much more reflective of what actually goes on. And it enables a lot of other things beyond what we looked at for modules today. And if you think about, so Webpack itself supports, if I list AMD, ECMAScript modules, and CommonJS, three very different module systems that are conflicting, but Webpack knows how to parse all of them, and it can generate them as well. So whenever you have anything to do related to understanding code with code and generating it, you almost always, I feel, see a parser. I don't have an exact reason for it, but it's just, to me, it makes the most sense. I can't really think of any alternative that wouldn't just kind of be hacky and get out of hand quickly. Yeah.
Thanks, Michael. I have two questions. The second one might not make sense. I don't know JavaScript at all. The first one is you used absolute paths and hard-coded those into your generated file. Is that how it works in the real world?
No. So I first read Webpack source code in 2016 at the tender age of 22. I was too young, but and back then I think it used integers. Like it had its module registrations array, but it would just get like a unique integer and stick it there. I think a more common thing that you can configure Webpack, you can tell it how to identify your modules, mostly for reasons of caching. This might not be deterministic what we did here. And by what I mean is our bundle might not look the same every single time. And Webpack definitely at one point did not generate bundles for the same input that looked the same every time. And part of that was because, random module IDs, order of processing, like V8 decides to, give you, like, process something else instead when you're traversing the AST. So I think more commonly what Webpack does now by default is it takes a hash of the file and uses that as a module identifier. And then it will probably sort those in some way to try and generate a deterministic bundle. So then you don't have your clients necessarily, if your bundle doesn't change semantically, but it changes syntactically, your clients will have to pull that down into their browser, bypassing their browser cache because the file changed, but even though it doesn't do anything different. So it's to stop things like weird cache invalidations from happening in your production environments that it tries to do deterministic ID mapping. Yeah, there was a lot of detail there. There's more I could talk about, but yeah, I think that sums it up.
Thanks. Second question, which might not make sense. Do you ever run into scope issues when you're just like slamming a bunch of functions together?
So we take a look at our code. This is another bug I would probably fix immediately, is that our modules and our loaded modules, and even our lilpack require, is modifiable by each of our modules here, just because we're using var. And we're using var because we could technically support Internet Explorer, But just because var is guaranteed to work in every browser everywhere. And this is just like not a good way of structuring this. I would like probably wrap a bunch of these in more like to guard the scope from, to make sure nothing leaks outside of the modules, right? But yeah, you're never going to use var in majority of code bases. All browsers that are evergreen now support it. Even if we used let or const here, we would still run into that same scoping issue, but we'd need to do it a bit more cleverly to avoid things leaking out, yeah.
Hello. At the start of the presentation, you mentioned that building something from scratch gives you a deeper insight into the tool you're using and makes you more effective with that tool. Do you have any examples of how this has basically improved your, like how you can work with Webpack and stuff, and what, like if you have any real world examples?
So I think when I was working at Top Hat back in, I think it was probably 2019 I did this, but we had a problem with like, we had a giant front-end monolith that didn't have a good separation in its package JSON between dev dependencies and development dependencies. So you have hundreds of dependencies there, and when you're upgrading them, dev dependencies, it's really easy if you know it's a dev dependency, because you can often just merge it once the build passes. If it's a production dependency, you maybe want some extra testing, like do some manual testing. So having implemented a Webpack from scratch, I said to myself, we know everything that's in the bundle. If it's in the bundle, it's production dependency. So I wrote a Webpack plugin that identified modules that were in the bundle and listed a warning in the Webpack output if you had listed them in your dev dependencies instead of your production dependencies, or vice versa, right? And it actually ended up working out pretty okay. And it got us towards like, oh, if you see a bunch of warnings, just like switch it and it works it easily. And there's some weird things that would crop up, like, because like things that would actually be production dependencies it would flag as development dependencies or vice versa, but those were kind of few and far between. And I never would have considered that as a solution, not having, I think, fully understood what Webpack was doing. So yeah, that's one example, I think.
Cool. It's a cool example. It's very smart.
Any other questions?
How come the bundle has to be wrapped in that immediately invoked function expression? Is that just to make the code run as soon as it gets imported in the script type?
It doesn't actually need to be, but it's just a habit I acquired from many, many moons ago, I would say. And it goes back to Chirag's question about scoping. It actually prevents anything in window from accessing the stuff we declared in there. So if we go into, hello Guy, if we go here and we search for modules, you see there's no modules defined here, but if we remove the iffy, so let's,
It ends up on the window.
yeah, let's just confirm that it does. I think it will end up on window. And then we reload this, and yeah, so it ends up exposed there. And this just goes back to the days of putting everything on window, like stick all your code in an immediately invoked in function expression and assign like the return value to window, or assign something to window like at the bottom where you're exporting things.
Oh,
Yeah.
okay, yeah, this is coming back to it. This is why we use module models.
Exactly, yeah.
Any other questions? All right. I think that's a wrap then. Thank you so much, Michael.
Thank you, everybody.